Question 6, forces. Figure 4 shows a rough plane inclined at an angle theta to the horizontal, where tan theta equal 3 over 4. If this is the right angle triangle, the opposite side will be equal to 3 and the adjacent equal 4, as tan equal opposite over adjacent. Therefore, the hypotenuse is 5. Root 3 squared plus 4 squared is equal to 5. Why did I do that? So I can find sine theta and cosine theta as a whole is equal to how much? Sine theta will be 3 over 5, opposite over hypotenuse, and cosine theta is 4 over 5, adjacent over hypotenuse. The point A and B lie on a line of greatest slope of the plane, with B above A, as shown in figure 4. It is very clear. Package P of mass M is projected up the plane from A towards B. The coefficient of friction between the plane and the package is 1 over 4. The package is modeled as a particle. Show that the deceleration of P as it moves from A to B is 4 over 5g. First step for a forces question, draw the axis, the force diagram. There is no forward force. The particle is projected, no driving force. There is contact between the particle and the plane, so there is a normal reaction in this direction. Weight vertically down. The mass of the particle is m, so the weight is mg. This angle is theta, which means this one is also theta. The direction of motion is upward, even though there is no driving force, but due to the projection, the particle is moving up. So the friction is opposite to the motion, so it is backward. Coefficient of friction is 1 over 4. 1 over 4 r, this is the friction. And let's do the resolution to the weight. Here I will have mg cosine theta and backward mg sine theta. Alright. Now let's write the equations. R is equal to mg cosine theta. R equal mg cosine theta. Cosine theta is 4 over 5. So R is equal 4 over 5 mg. And forward minus backward equal mass multiplied by acceleration. Forward is 0. 0 minus mg sine theta. 0 minus bracket mg sine theta is 3 over 5 mg plus mu r. 1 over 4 r. 1 over 4 multiply r, which is 4 over 5 mg. All that is equal to mass multiply acceleration ma. Simplify. Negative 3 over 5 mg minus, when the minus enters the bracket, minus 1 over 4 multiply 4 over 5 is 1 over 5 minus 1 over 5 mg equal ma. I can divide the whole equation by m. So the acceleration will be equal negative 3 over 5g minus 1 over 5g, negative 4 over 5g. This is the acceleration. And when the acceleration is negative, this means I am decelerating. The deceleration is the absolute value. So the deceleration is equal 4 over 5g, as he wanted us to show. Show that the deceleration is 4 over 5g. Done with part A. Part B, the package P comes to rest at B, which means that the final velocity is 0. The final velocity at B is 0. Given that P is projected from A with a speed u, and that AB is 1.5 meters, find the value of u. This is the part of kinematics. Part B, the final velocity is equal to 0, and the acceleration is negative 4 over 5 g. Displacement, given that AB is 1.5 meters, find the value of u, the speed of projection. VAS and u we'll substitute in v squared equal u squared plus 2as. V squared is equal to 0 squared, which is 0. U squared, the unknown, plus 2 multiply negative 4 over 5g multiply 1.5. Simplify, move this to the left. 2 multiply 4 over 5g multiply 1.5. 23.52 u squared is equal to 23.52 under the root 23.52 4.85, three significant figures. U is equal to 4.85 meter per second. This is the value of U. On reaching B, P is held at rest there by a force of magnitude x newtons acting up the plane in the direction of AB. Given that the mass of P is 2 kilograms, find the smallest possible value of x. Alright. When the particle reaches B, there is a force of magnitude x newtons. Its direction is up the plane. Normal reaction, upward, weight as it mg cosine theta, now 2g cosine theta, and backward 2g sine theta. He wants the smallest value of x. The smallest value of x, so I will put the reaction with x. Mu r will now be with x. 1 over 4 r. When he asked for the smallest value of x, it is like if he said the particle is on the point of slipping down. So I need a friction upward to balance with the x and the particle to stay in equilibrium. Now r is equal to 2g cosine theta. This is part C. R equal 2g cosine theta, which is 4 over 5. And 2g sine theta is equal to x plus 1 over 4r. The particle is held in equilibrium. 2g sine theta equal x plus 1 over 4 multiply r. R is 8 over 5g. R is equal to 8 over 5g. Sine theta is 3 over 5. 3 over 5. So now in the left hand side, let's simplify. 6 over 5g equal x plus 2 over 5g. So x is equal to 4 over 5g. This is the smallest possible value of x. And the unit is newtons because it is a force. Next one.